Okay, so as explained in the class, for this experiment, we need a software called Arduino. So you have to go to the website of Arduino. You can type Arduino IDE if you want, and you will come to this first website called arduino.cc. You have to click on this particular website, go to the either download section or it's directly available. It's showing me version 1.8.13, and now there are some options here. So the best option is you go for Windows installer, but if you don't have admin rights, you can go for Windows zip. And there are other options like Windows app from the Windows store. If you have Mac running OS, then you can go for Mac OS version, and then different Linux versions are also there. So if you don't want to go into those downloaders, you can directly go for web editor also, which is code online. But I would always prefer that you download this IDE and run it. So here I guess I have already installed Arduino IDE with me. So but you can start doing download by the time I explain this thing. Simultaneously, then you can do the extra. So it will ask me some security alert. You can give access, uh, and then it will ask for new version. So mine is not the latest one. Right now, I don't want to update, so I just kept it as it is. Mine is 1.8.12 and current one is 1.8.13. So only one version up is running now. You won't get this error because you are downloading it today. And as soon as you start this coding, you will get two things, void setup, and then there is some blank spaces, and then void loop, and then there are some blank spaces. Now, as per
सर
the, yeah,
सर वो जो एक्सेस अलाउ में अगर हमने कैंसिल कर दिया तो वो वापस कर सकते हैं क्या?
the, I guess you can just close Arduino and restart, then it will ask you again.
ओके, ओके,
It's okay even if you don't allow it to connect to net because you are doing it offline right now. So there is nothing gonna be through net.
ओके सर.
Now, the basic code which we learned in the class is under the file. I guess go to example, go to the basic and click blink. So this is the basic code as I mentioned. This is written by someone and somebody's name and some explanation will be always given as long as you are downloading it from the net. And this part is not needed because it's not a part of the code. The main code starts here. I will just try to uh, zoom in a bit so that you can also see. So the first line is void setup. It is the part of the code that runs only once. Then pin mode. Here you can say pin number 13, which is the blink LED as output as explained in the class. So this will put my pin number 13 as output. If you want any other pin into the output mode, you can do the control C, enter, and then press control V. And then you can do any pin number like 12. It can start from 0 and go up to 13. So total 14 digital IOs it has. Plus then it can have A0, A1, A2, A3 and so on. So 6 analog pins, A0 to A5. Then function loops forever. Here we have to write void loop, digital write. So I will set pin number 13 as high. Then delay of 1000 seconds, digital write. Then again pin number 13 as low, and then delay of 1000, and that's it. So this is first code of blinking a LED. I will
I
copy
will
paste
copy
this
paste this.
code into your chat box. I guess. Yeah, there it is.
So that is 1000 seconds or milliseconds.
It is
It is
1000
1000
milliseconds.
milliseconds.
Okay.
So if you want to blink it fast, you can reduce this number to 500 milliseconds. That will be half a second on and half a second off, and so on. Okay. Now, similarly, you can do multiple things with this. Like you want to keep that LED on for very long time, you can make it 5,000 seconds on, maybe just 50 seconds off, and so on. So you can just play around with this, and every time you do a code, you can just verify the code. So once you click verify, it will say compiling the score. And if you have Arduino with you, just plug it to your USB port and click on upload. So this code will get uploaded. Now, other options in the Arduino, you have to look for this board. So typically we have Arduino Uno board, but there are these many Arduino boards and there are many more. And if you have any specific kind of board which is supported by software, then you can go for this Arduino board manager. Let's say you want to install some Node MCU ESP8266, and then it will show you that particular ESP8266 boards. So these are the different boards available. Everybody's driver is into this, and you can just update the selected version. So you can select the latest version and click update. It will download that particular board for you into the Arduino IDE. So there is huge number of boards which are already mentioned, and then further you can keep on updating because these boards are keep coming. Second thing is you will see something called as port if you plug in your Arduino. Right now I have not plugged anything, so I am not getting anything here. Then you can take a board information once you plug in. Also, there are some options like serial monitor where you can see what is the data sent by the Arduino onto your serial port. There is something called as serial plotter also, which does the exact same thing as serial monitor, but if the values are numbers, then it can directly plot it. And then if you want to burn the bootloader into the Arduino, you can select the type of programmer. If you purchase a new Atmega 328 IC, which is not made for Arduino boards, then you have to burn the bootloader of Arduino before it can be used with Arduino. And this is the typical problem that people face कि Arduino के ऊपर का Atmega 328 उड़ गया है, so they don't bring the new Atmega IC. They have to get a Atmega IC which is already burnt with bootloader, or they have to get a fresh IC and then the bootloader needs to be burnt onto it using one of these programmers. So if you don't have these kind of programmers, you always go for Atmega 328 IC with Arduino bootloaded. Now, what is the bootloading program? It's just like an operating system loaded onto the Arduino, for Atmega, and then you can run your Arduino programs through that operating system. So bootloading is very important. Otherwise, there are some settings of Atmega 168.328 which you cannot do. Uh, so as per the programming concern, I guess today's experiment is about reading let me check what is the today's experiment. LDR readings, I guess. So we want to check the light display readings, and then uh, we'll just download the experiment list. Experiment number, I guess today it's 5, 6. Okay, experiment 5. Okay, so this is an experiment where we want to interface a LDR with Arduino Uno and read the readings. They have mentioned serial terminal. We will see how we can display the same readings onto the LCD also. Demonstrate the microcontroller. So there are some steps need to be followed. Stepwise procedure it. Start working. Okay, so these are the questions. We need some writings to be included here. So along with that circuit diagram, I will download this write up and do it with you so that you are not lagging behind. Now, since we are going to run it on simulator, it is always better to have some display unit along with this Arduino. So coming to the circuit diagram, I will just draw the circuit diagram in Paint for you, and then we will put the actual circuit diagram also. So somehow it's lagging. I don't know why. Okay. So this, let's say this is your Arduino Uno. You have to put one register, the other register, which is your LDR, light dependent register, grounding. This goes to VCC, that is plus 5 volt, and this particular pin goes to A0 pin of your LDR. So this is the connection for the LDR. Now let's say LDR basic resistance is 10K. It is preferable that you set this value to 10K as well. But any resistor will do. Accordingly, we have to compute for the voltage division law, that is R2 divided by R1 plus R2 into VCC. So this is the voltage across the LDR, and as the light changes across this LDR, the output should change. Now, next thing is, let's say we want to display this output onto certain LCD, which is 16 cross 2 LCD, and then there are 3 pins like to RS, enable, and then read write bar. So there are total 7 connections from LCD to Arduino from 7 digital pins. We will learn about this later, but let's assume there is some connection between a LCD so that you can display this value onto this LCD. Now let's go back to your Proteus simulator and see how to do it. Now, one problem you all might face along with me is we all are running the demo version of Proteus, and because of that, it won't allow us to simulate the code. But still, I will show you entire procedure, because in case if we get the original version when you are back in college, or in case if you get a cracked version which you can run at your house, you can follow these steps. So for that, you have to click on File, New Project. Now it will bring you to some option which is by default. Not all the time we click next, 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 next. This time we have to click from development board. Okay. Now we want to select a development board of Arduino Uno with Atmega 328. That is what I will choose here, and click finish. So there are no options this time, much next, next, next. You just have to do this. It will replace the existing project. That's okay for me. I have done it before, that's why. Now, once you reach to this point, you have to right click on this one. Okay. If you double click on this, it will ask you to feed the point, that is PCB layout. We don't care about, but what we care about is program file, which you can browse and put your hex file, which is generated into the same folder where you will store this blink. So I will do this now. I will go to the file. I will click save as, maybe somewhere on the desktop. Let me put this blink file and click save. So this blink .c file is saved, and as soon as I click this compile, it will actually generate a hex file for it on my C drive down desktop. So let me go to the desktop and check for this blink folder. So currently the blink.ino file is there, which is my original file, and as soon as I click this, it will start generating the code. And we have to see that wherever you install the Arduino, will the folder will tell you where the hex file gets created. Okay, so this is the one way to generate the hex file from here. Otherwise, we have a simpler option. Once you compile and verify the code over there, you have to go to the edit firmware, and it will bring you to Proteus's Arduino compiler. Now you have to, you can see it's the same thing which got produced on your Arduino, and its main.ino file is there. So either you can directly browse a file and put it here, or you can copy this entire file from Arduino IDE and then paste it here. Okay. So this is the way you can do it. You don't need pin number 12 and 13, so you can just delete. And if you have license, you can directly run from here. But since I am using a demo version, it will throw me an error saying that AVR compiler is not found, or your license doesn't support this compiler. and it will say firmware failed. Even if you try to see everything is already set, it will also use this Arduino Uno 3.x, but when you run it, you will see an error. So it is running the simulation, but at the same time, let me check. Uh, so when you run it, uh, your pin number 13 is not doing anything. So because it doesn't got updated, we will still try to put an LED and check whether it works or not. I already have a yellow color LED, which I will put here. At pin number 13, which is DIO 13, this is the pin. So I will just take my connection there and connect it. And the other end should go to the ground, which is already here. So I have connected it, but I don't think it will run. Yeah. So it is saying that your sample file VSM requires a module which you don't have under your product license key. You can only simulate if you change the connectivity of the schematic. So this is the problem with free version. It won't allow you to simulate since AVR to DLL is missing. We don't have the license to run it here, and that's why we have to use a third-party simulator. So now I will take you to this third-party simulator also. By this time, you might have downloaded the Arduino IDE, and now you start installing it. Click next, 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 and finish. And once you install this, you have to press this Windows button and start typing Arduino. You should see this Arduino app. Now coming back to the circuit diagram, you know how our circuit should be. You have to connect a simple LDR, and to simulate that in Proteus, we can still do without Arduino also, just to see whether the connections are right or wrong. I just remove this everything, and if I run now, I should not get any error. Nothing to simulate. Okay, that's okay. Let me go back to LDR. So just to explain the principle, I am doing this. I just put the value of LDR here, and now I will also need a resistor. So let's say 10K 1 watt resistor I used, put it in series, and then this is the kind of connection I did. We need a DC source with 5 volt supply, and then a ground. So this is the input that's gonna go and connect to the Arduino analog pin. So just to measure it, I will right now connect a DC voltmeter, and we will see whether it actually changes or not. And now when you run, I'm getting 0 volts because I didn't apply any supply voltage. So let me change it to 5 volts DC, and I'm getting 4.96. So this is where the tuning matters. The resistor value, it should be always around half. So I just try and changing it to 10K, and then I will see the output voltage 4.64. So it looks like the LDR is having very high resistance right now. So let me put something like 50K. So more the value of this resistor, more will be the drop. And now it is 3.59. So if I increase the light, you will see LDR resistance is going down. And as the light is increasing, the values have changed from 1.39. And if I keep on reducing the light, you will see the voltage is increasing. So this is the correct circuit. And now we have to use the same circuit for our simulation. We need another software that supports Arduino simulation called, I guess it's called Tinkercad. Tinkercad, it's a free software. So you have to click on tinkercad.com. Since I already have login, it should log me in directly. It will show your name here. So I will give you some time before we start with Tinkercad simulation to do all these things. You have to click on the circuit and then we will continue in the next video.